Okay. Um, so this is our last lesson for similar polygons um, and and scale factors and scale diagrams. So far you guys have learned about how to draw a enlargement or a reduction, how to find a scale factor for an enlargement or reduction, and then you guys got to look into similar polygons, so similar triangles, similar polygons, and then solving some problems there. So now we're going to look at some more real world context questions. And then you guys are going to just do some problem solving ones. So I'm going to do one example for you, and then you will get to complete one, or I believe it's like 5 questions on your own. Okay? So the example we have here says, a man would like to measure the distance between himself and the lamp pole. So he wants to measure the distance between himself and this here is the lamp pole. His shadow measures to be 57.8 centimeters. So if I were to put that down under his shadow, that would go right about there. Okay. And his height is 180 centimeters. So far we're good with our units. Everything is consistent. So 180 centimeters is his height. If the lamp pole is 340 centimeters, then we're going to figure out the distance between the lamp pole and the man. So we want to find x, and we're going to call this x. So the distance between the lamp pole and the man is right here. So this little distance right here. Okay. So if you take a look at this question, we have 2 different triangles. It's kind of hard to see them, but I'm going to outline them for you here in 2 different colors. So let's do red for the first one. So your first triangle is this large one here. Okay. So this is our first triangle. So if I were to redraw that triangle, if I were to just take, here we are, I'm just going to put on the side here. So if I'm just going to draw my triangle on the side here, I'm going to write down my units, and I'm going to make sure this is red. So we align ourselves with the one that I just drew. So with the red triangle that I just drew, we have some measurements. So we have the 340, which is that length here. And we actually don't know the full length on the bottom. So we don't know this full length. We know that it's 57.8 plus something, but we don't know what that something is. So I'm going to label it Y, because I don't know what this length is right now for this triangle. Okay, so I just kind of made a smaller version of it. Now, if I were to do the same thing, but for the other triangle, so I'm going to make it green. So this triangle here is my second triangle. So this is my second triangle. And you are going to notice that we have 2 side lengths for this triangle. So if I just draw it here, then I have 2 side lengths. I have 180 and I have the 57.8. Okay, so now that I have these 2 side lengths, this one's my big triangle, this one's my small triangle. Now, before I can assume that these triangles are similar, let's take a look at what happens here. So, if you guys remember from my previous lessons, and we'll make this black, is that we need to, all angles of a triangle must be equal, or the corresponding angles must be equal in order for these triangles to be similar. So I know this is a right angle triangle, and I know this is a right angle triangle. okay? Because we're measuring height. So a lamppost, if I'm going to measure its height, well, this is going to be 90 degrees, and the same with the man. He's going to be standing, and we look at height with a 90-degree angle. So I have two 90-degree angles in each of my triangles. So right now, they each have a 90-degree angle. What they also have is they both share this angle right here. So they both share this angle right here. So right now we can assume that these triangles are similar because if these two angles are equal and these two angles are equal, then these two have to be equal. Okay? They're similar triangles. So we are going to use what we know about similar triangles in order to find our missing value of y. Okay? So to do so, we are going to find my scale factor. So the only way I can find my scale factor is if I look at my two known side lengths. So I'm going to label the big one my original. So let's make this one original. And then we'll make the green one my scale diagram. Okay. So let's use what we know to find our scale factor. So we know that scale factor is equal to scale diagram divided by the original. Okay. So it's divided by the original. Okay. Now that I have this formula, let's find my scale factor because I don't know what my scale factor is. Okay. So to find my scale factor, I need to plug in my values. So we are going to use the corresponding side lengths, sorry, here, grade 9s. Corresponding side lengths of, we're going to use the 340 and the 180 because I know those two side lengths and I know that they're corresponding. So my scale diagram is 180 and my original is 340. Okay, so when I divide these, 180 divided by 340, I'm going to get 0.52529. I'm just going to leave it like that. I'll round to the nearest thousandth. Okay, so now that I have my scale factor, I can now find y. Because they're similar, their scale factors are going to be the same. So I'm going to use this formula again, but this time, just change the color of it so we understand that this is a different section. This time what we're going to do is we're going to use it but plug in the information for the y and the 57.8. So I know what my scale factor is. It has to be the same because they're similar polygons. My scale diagram, well, my measurement is 57.8, and then my corresponding length on my original is y. So I'm going to plug in y here. Okay. I'm just going to move this down here because it might be a little cleaner. Move this over. Okay, so now we got to find y. Well, I showed you how to find y. I showed you, oh my goodness. I need to move this up and this up. Okay, so I showed you that we need to isolate for y, but because it's in the denominator, I do not want y in the denominator. I'm going to move it up to the numerator. Well, to do so, I'm going to move it over to this side. And the opposite of dividing y is multiplying y. What I do to one side, I need to do to the other side. So I'm also going to multiply by y here. Now remember, these are opposites on this side. So because they're opposites, they cancel, well, I don't want to say cancel each other out. I'm going to cross them out, but remember, y divided by y is just 1. So I'm left with 1 times 57.8, which is just 57.8. So those are gone now, and I'm only left with 57.8. And on this side, I am left with y. Okay, because 0.529 times y is 0.529y. Okay, now what I'm going to do to both sides is I am going to divide. We are going to divide by 0.529. Why? Because I want to get y by itself. And what's attached to that 9 is that 0.529. So what I do to one side, I got to do the other side. And then you should get your answer for y. So y now equals, if I put this in my calculator, 57.8 divided by 0.529 equals 109.26. Okay, so that is what y is. Now we're not done because we found y. We need to find x. Well, I know y is this whole side length here. So y is this whole side length. So if y is this whole side length, well, to find x, don't I have to go y minus 57.8? So I gotta go 109.26 minus 57.8 to get what my x is. And we will get our final answer. So yes, a lot of steps, a lot of things you need to do. But this is basically what you've been working up to, is you have been working up to getting answers to questions like this. So our answer is 51.46, and we were using units of centimeters, equals x. Okay, so that, my friends, is how we would find the answer to a complex question like this.